So it's Sunday. I've just done my church service via Zoom from my pipe organ restoration workshop where we have a finished organ, so that was fine. And just to finish off that Murphy CB2000, which had all those silly modifications and power up the mic socket, I think what's his name, 21, not Tango 21 like me, Box 21, I've forgotten his username. He said he checked with his one of his Cybernet sets, not a Fidelity, and he said it was 16K for the dim. And so I've put 16K in, and we have exactly the right amount of dimness. I can think of some people like that as well. So that wraps that setup. So that was well done on Mr. What's It Box 21. Right, it's Murphy base station time. Well, this certainly looks like it's been in the wars, doesn't it? I think as it's been tossed into a skip, it's got dented. Yes, that's not one careful lady owner. And it's had some nasty stuff put round it, some kind of sticky back plastic which has left it. He's got the front bezel or escutcheon, whatever you want to call it, for this. They look like they would fit my record player that's got one missing those feet. They're not the original. Okay, well, we're going to have to take all the lids off this, and so I will just go and do that. I was going to tell you a story. I told you about the Amstrad 900 yesterday, the one that had been put across mains, brand new. Oh, I know what it was. Our main business is in church pipe organ restoration, and that's work I did a proper 7-year apprenticeship for. And we installed one of our used pipe organs in a church. I think it was in Iowa. I mean, we're going back to 1983. I wouldn't do overseas contracts these days, but you know, did at the time. And we were replacing an electronic organ with a real organ, and as you can imagine, it was something they were looking forward to having. But until we'd finished installing the pipe organ, the electronic organ, which had been using for some time, was still in place, and they were going to sell it on when we'd done. Now, you'll be aware that in America, the CB radio system is AM, amplitude modulated. And I was one of the people very, very pleased when we got CB in the UK that it was FM, and on a totally different set of channels. And is it something like 12 times the amount of interference on AM? I forget the theory. Long time since I did that. But anyway, the minister was in the pulpit with a very fiery sermon, how we're all going to go to hell in a handcart. And to drive his point home, he said, "And may this be..." Now, what was it? "And if this not be so, then, you know, strike me down now." And right at that moment, out of the loudspeakers for this electronic organ, as interference into its amplifier, no doubt a truck driver just passed the building and just said the appropriate words at the appropriate time. And those words were a big 10-4 on that good buddy. So you can imagine this minister driving his pointer, "And may God strike me down if this not be so." And immediately, a big 10-4 on that good buddy bellowed out of these speakers, where you can probably imagine that the congregation fell to their knees. Well, I knew what was going on. You could read you could read all kinds of things into that. But these little silly little stories over all those years ago, they can still make you smile from time to time. Okay, so we've got into it. And as you know, these are a Spirit 40F. And we don't know why that capacitor's like that, but it is. I think what we're doing now with any mains powered radios is we're replacing all the capacitors in the power supply as a matter of course. Now these are 38 years old, and that could well be another candidate with it. So I don't know whether it's been swapped. It looks like it's been swapped, but it's had its legs not stopped, not cut. It's loose. Well, I think we'll start by, I'll look at the circuit diagram, make sure that's the right value, and we'll take it from there. So before I even power this up, I'll take the precaution of changing these capacitors in the power supply. And that one is starting to recede with its shrinked tubing, which has got the part number on it, so you know that's not long for this world anyway. So I'll take those out, and they've not been messed with, I don't think. I'll check with the circuit anyway. I'll just pull up the circuit and we'll take it from there. So I'll pause the video while I do that. Okay, so we'll test some of these which I've just taken out. You like the pink sticky notes? Right, so the first one, capacitor 141, is 100 microfarads, 25 volts, and we've replaced like for like. See, that's slightly high, so indicative of it failing. It's more than slightly high. Don't for 1 minute start to think that high is good. Exactly the same. For some reason we've got 470 microfarads. This is a modern replacement. It's supposed to be 100 in that position. Now then, that's reading low, and I tell you what, they've put 16 volts in here and it's supposed to be 25. So you have to appreciate that power supplies, the regulation works at about 26, 27 volts, and through the electronics it drops it eventually to 13.2 or whatever it's set to. So you think, oh, power supply, you know, it's a 12 volt power supply, but 16 volts isn't good enough. So that's come out 4700. I'll have to see where that is on the circuit. So I haven't replaced that yet. Let's see how that's doing. Yeah, that's probably all right. And then finally, from position 3, we've got a second-hand capacitor in there, which is a more recent replacement. And it's absolutely spot on, but it's not going back in with leads like that. So yeah, 1000 at 35 volts sounds right, but I will have to just check up the value. So work in progress. Okay, well the biggest problem I've got now is that the mains lead's only 2 feet long. So I've had to unplug the synod meter, which is on a socket in front of me, to plug this in. So when we come to read the synod, I don't know what we're going to do. We'll probably have to run the radio off 12 volts, something, I don't know. Mind you, we never might not get to that stage with it, might we? So let's plug in the instruments into there. So we've put the capacitor back there, replace those with new, replace that with new. According to my manual, it's supposed to be 1000 microfarads, but according to my manual, my circuit diagram, but that's 4700, which I don't know whether is correct or not. I haven't got another set to compare it with, so there we go. So we have a microphone, and let's switch to picture-in-picture and we'll see whether this radio is working. It's on channel 20. So going into transmitting, we don't have any transmit, so let's just make sure we're in the correct position. Okay, so we've got no transmit. Let's see whether there's any receive. So I'll put the signal generator on. Might be sensible to see where we are with the power supply as well. .76. That's absolutely where it should be. I'll put that back a moment. So it looks like we've got a VCO anomaly. I'll have to do some guesswork as to how to set that. I might have to have a look at the Sanyo data sheet. Well, I think we need to see whether we've got power onto the pin there. So if we use the Rotel service manual, because it's to hand, uses the same synthesizer. So it looks like pin 20 is the power to it. See whether that gives us rail voltage. It does. Good. So we go to pin 20. 4, 5, 6, 7, 8, 9, 10. That's the last pin. Have we got a rail voltage? We have. We should have 6.6 on 18. We have. So what's on 15? 10, 11, 12, 13, 14, 15. That's the circuit specific for this radio, and this is all we have, nothing more. So around the synthesizer, I'm just wondering if they do show a test point. Their test point 1, but where does their test point 1 go to? I don't think it's anything to do with the VCO looking. Oh, yeah, it could be. So resistor 75, resistor 76 could be the VCO test point. The trouble is, it's got wax in it, hasn't it? Oh, look, we've got a ground pin. It actually says ground. Let's just prove it is ground. Yes, it is. I think that says test point. There's two 22k resistors by it, and it's 22k resistors showing. So let's see whether we can alter the voltage. Right, well, it's not going to be any further up than that, so we're going to transmit. Trouble is, trying to hold that on there. So the next question is, does that vary with channel selection? That's channel 1, that's channel 40, and it doesn't vary. So we've definitely got a situation where the synthesizer is not running. So what's being dragged down? The only voltage we're shown on here is pin 18, which should be 6.4 volts. Pin 18. It's 5.9. So I can't see we've got any power rail voltage totally dragged down. The thing is, you just don't know what's happened to sets, do you, when they come in like this? Well, I'm tempted, first of all, to change that electrolytic and that electrolytic, just for the hell of it, and then we'll go into some deep fault finding if it doesn't bring it to life. Okay, so we're getting somewhere. Having changed the electrolytic capacitor there, I changed that one there, but that one was faulty. We started to get some different voltages then on the synthesizer chip, and replacing the synthesizer chip has brought back transmit operation, but at, if we look at that meter, it is 1.25 watts. So we've now got receive. The radio's miles off frequency, but that'll be down to the reference crystal. And so what I've done, I've set the signal generator to what the radio's transmitting on, and I'm just going to see if we can kind of get something out of the receiver which is less garbled than this. Not a cheap repair. I think those synthesizer chips are about 14 quid these days. Let's get the right camera on. I think we want 3. Put the oscilloscope on. Sounds to me like the detector's miles out. We'll give it S9. And the detector's down there under the mains input. Oh, of course. We need to plug in the speaker, but it doesn't have a socket, does it? So we have to plug in via the back of the speaker. Hopefully we only need one. We do. So it's just the inner to the top of the speaker. That brings us the instruments. So let's see whether we can make it sound a bit more like a radio rather than the square wave generator. Yeah. It's like that, is it? We'll quickly run through some of this with the synad meter, just see whether we can do something with it before changing more parts. Now, of course, I can't switch on the synad because I'm plugged into the synad machine socket. I'm just going to do some of this by ear, which is wrong, but I just need to make sure we're heading in the right direction. So that's 1 microvolt, so you know, I think we're getting somewhere. So what we'll do to keep his cost down, I'll pinch a crystal off a scrap chassis, and then hopefully we'll bring him on frequency. So one of the other problems with this radio is no audio on transmit. So came with what looks like a brand new microphone, and I just checked that the pinout was what we have, and it is, because it's quite unusual. If I get the chart, it's pinout number 7, and it's screen PTT audio, so there's no receive on these. So still got no transmitted audio. So looking around the audio circuit, and I found that we got, I could just touch on pin 3 of the speech processor IC, which is down there, double op amp, and I could just get a bit of a buzz on transmit with my finger, and I thought, well, we've got a electrolytic capacitor there, and seeing as an electrolytic capacitor of 4.7 microfarads was one of the problems with the phase lock loop, I've changed that and we've now got back audio. So if I get the monitor receiver, 1 2 1 2, testing 1 2, there we go. So that's brought back audio. So that's I'll show you on the deviation meter. I will. Wallow, testing 1 2. So we've got that back, and that's working as it should. So we're getting there bit by bit. What we haven't got is much transmit power. We've got 1.5 watts. And one of the snags I've got is the core down here. I'm going to have to move this camera down because it's such a big radio. Well, it is for our bench. The yellow one there, the core is absolutely stuck in there. So whether or not I can get that out with one of the tools we don't normally need to use, perhaps it's the white one that fits. The difficulty is, what are we going to put in its place when we've got it out? It'd be funny if the yellow tool fitted the yellow core, wouldn't it? Yeah, wouldn't be that lucky. So, what we're going to have to do is to take the screen plate away from underneath, and we're going to have to unsolder the coil. We've got that. I'm going to have to move the camera again. We've got this big screen plate here, so I just need to take that out. So, right, we'll battle on. And this is why we have some scrap chassis around. Now this is the remains of an American, and therefore illegal in this country, messed about with some Synchronic realistic set from the 70s, and I paid £2 at a Radio Rally for this chassis because it's got some unusual cores in it, and we've already had one of them, and we're about to have this other one. And I think this is going to be the right size. Might be wrong. And there goes the phone. Okay, so having spoken to Mrs. Ex-Nurse on the phone, I do shopping for every other Wednesday. Is this camera in the right position? It is now. So the core off the 1970s American realistic set fitted. And let's see whether we have any luck with transmitted power. Okay, so we're now down to 1 watt, so we'll get this to the correct position. No. So in actual fact, the broken core was in the right position. But we didn't know that, did we? It's also possible that Mr. Coil Stretch has been inside this radio. So that's something else we need to look at. So that's definitely at peak. No, so we're at 1.5 watts. I'll have to look at the spectrum analyzer for the coil stretching outcome, but I'll just have a look because it's that one that's messed about. Right, we've got that pretty well balanced. So on channel 20, we've got 4.05 watts. That'll soon drop down when it warms up. On channel 40, we've got 3.95. And on channel 1, we've got 4.05. So that's as balanced as I can balance it. So we'll just need to look at that on the spectrum analyzer to make sure there's nothing which the phantom spring coiler twazzler has fiddled with. So we'll just select that on the system. So on the spectrum analyzer, we've got our fundamental at 27.79125. We've got our naughty and we've got to make sure that's within specs. I need to measure that. It needs to be better than -74. Seem to recall. We are actually okay, we're in spec on that. Right, so there we are. That's that done. In fact, we can... No, I won't switch it off, or I'll end up switching it back on again. So we've got transmitted audio. Wallow. Yep, we've got transmitted audio. So we need to set the RF power meter, which at the moment is banging across beautifully. Now, does the power meter have an adjustment? I'm probably going to have to look at the circuit diagram for this. So where's the meter? So we've got the meter there. So we've got, that's the S meter. We've got variable resistor 1, it looks like, which goes to the transmitter. So variable resistor 1. Oh, is it that one at the back? Of course it is. So that needs to be in the centre of the red zone, which it now is. Now on these sets, high-low power isn't adjustable, but we'll go back to the camera just to show that. And in power mode and low power on the machine, it's doing about 0.2. So there's nothing, you know, that's just the way it's made. So that's transmit done. So it just leaves us with receive. We're going to have to rig up an extension lead, so I'll switch this off, go and have my tea, and I'm going to have to come back with an extension lead, because 2-foot mains lead on this radio isn't enough to get to our socket. Okay, so we'll move on to receive, and we've now got the cyanide meter, hopefully in view on there. So we're listening to 1 microvolt, that's 0.3, so knock it down to 4 decibels and see whether we can tune the radio. Most of the cores are broken in this. I can't do anything with the first one because it's broken, so that will need to come out and be reversed. That's very tight. Try the metal tool. I don't move them. I actually suspect all 3 are broken. Well, let's see if we can do the IF ones. Not sure what that one does. It's definitely the receiver. Well, that's one we've peaked. Push that up a bit. Just check the detector once again. Yep. But at the moment it's pretty deaf because I can't shift those three. So we're looking at, for 12 decibel cyanide, at the moment we're looking at 1.5 microvolts. Well, the radio can do better than that. So I'll start by unsoldering that one. Right, so the core wasn't recoverable from that. We've had to put a random core in that fits. I've managed to turn this one round. And what's that brought our sensitivity to? Oh, it's... what? Oh, we're now at 1 microvolt. Wow, will we improve that? Alright, we'll see whether we've got an improvement with that one. I'll come disconnected from the test gear. So I was able to turn that way at one round too. Right, let's see where we are. .9 isn't good, but what are we going to do? We can't replace the coils, can we? It's not like a set where you can delve into a scrap chassis. So each one of those has been broken. So we'll now just check that I really have got those IF1s at optimum. see if we can get 20 dB. We can. I know this has had filter issues in the past because he told me. Right, we'll give it one more go. We're in spec, but we're not bang on. We're well in spec. I wouldn't let it go. But, you know, you've got capacitors inside these coils, and if they degrade, that can alter the way the tuning is. So, you know, between the broken cores and that, I think that's about as good as we are going to get. At the end of the day, each of these 4 sets, which I've had from this customer, were actually beyond economic repair. And I did them in order of what I thought would be doable. And yes, they've been right corkers. So we need to just do the S meter. So we'll put S9 on it. S9... showing 1. Now which one's that? So we've got the meter, goes up to VR4, which is the transmit one. It goes across to VR1, which is what I was fiddling with in the beginning, and VR1 is actually labelled, and it's that one in the corner. I'll move the camera down because I can do that. Gets the tool out of there. There we go. I remember the fun we had with the meter on the last one of these that came through, and it had super glue in it. I did my best with it. Right, that just leaves squelch. There we go. So we're going to park that at 30 microvolts. And we're going to turn the squelch up to full. And it's cut out, which is what we want. We're now going to advance the signal generator to 100 microvolts, and I want it to come in. So it's going to be that preset there. Well, one would have hoped so. We'll just turn that to minimum, the squelch control to maximum. No, it won't set up how I would like it to set up. So on full squelch, I can't get it to open ever. And that is far from ideal. I can make it stronger. Don't want that. So we've got a minimum squelch. Yeah, so... no, it won't set up how I want it to. Okay, we'll do the other end and make sure that's going to work. Alright, so I've parked the signal generator at 0.3 of a microvolt. We've turned the squelch down on the radio. And we'll switch the signal generator off, advance the squelch to threshold. Switch the signal generator on. Now see when it comes in. Oh, that's awful. And the answer is 3 microvolts. I'll try that one again, see whether we can set it better than another go. So radio squelch to to off. Carefully, even more carefully set to threshold. Okay, that's really on the edge. Switch the signal generator on, see when it comes in. Okay. So it's coming in at 1.9 microvolts and leaving at 1.5. And that's the best I can set it at. At the end of the day, they're not a brilliant radio. They're very popular. This one's doing 4 watts, which is great. They've always got that transmit hum. What more can you say? And 38 years later, they're still not a brilliant radio. I don't know what we're going to make of the current generation sets that aren't brilliant radios new out of the box. But these were the Spirit 40F transportable in a big box. So it is really a walkie-talkie in a big box with a power supply. And you can't expect it to work as a custom base station might have done. But name a custom base station, because they all had mobile boards in them, didn't they? The Cybernet ones did. And even those Saruga ones, like the Grandstand and Atron and Wagner, they still had the Grandstand Gemini board in. So, yeah, there you go. So, that's as far as we're going to get with it. And we'll do a Scratchy Corner test. And let's hope that we hear him at Scratchy Corner. So, this is probably the worst condition. I will just do the defluxing of that board. This has got to be the worst electronically conditioned Murphy CBH1500 I've ever seen. But at least the meter's okay on this one. And that's been quite costly to fix. I'm talking about 20 quid in parts. Well, I've found out what's killed all this electronics. These wrong feet which have come off somebody's record player, they've been put in with self-tappers that are so long that these self-tappers, that one, because that's a shorter screw, that's a machine screw, that self-tapper actually mates up with the printed circuit board. So that's what's happened to it. I just started to put it on, it just started, I thought, that's not right. So that is the cause. I think we'll just cut that off with some big cutters. And just for those people who like to look at Zetagi watts, here's the Zetagi watts. It's doing 4 real watts, so let's see what Zetagi watts it's doing. Ooh, just under 5. Can't be bad. Right, we'll just pop it on the aerial. I know the customer said he got all these out of a house clearance. Okay. One on a Roger. Okay, there we are. The Murphy CBH 1500, they were about 1982, 1983, and electronically that's the worst one I've seen. Thank you for watching.